Hello Pre-Calc PC. Today we are talking about the dot product, which is one way of multiplying vectors. Now, we don't want to call this times or multiplying because there's actually another type or another way to multiply vectors called the cross product, which we'll be talking about in the future. So we want to call this the dot product as opposed to multiplication because that's not super clear what we actually mean by that. All right, it also isn't going to look like the multiplication you are used to with scalar values. All right, so here's how we do the dot product between vectors. If vector v is a1i plus b1j, and vector w is a2i plus b2j, basically, in order to do v dot w, and this is the correct way to say this, v dot w, you are just going to multiply your x components and multiply your y components, and you're going to add them together. What this means is that when we do the dot product, we get a scalar value, which is just a number. Okay, so we will not get a vector anymore, we will get a number. All right, so let's show you how to do this. Here we have a vector v and a vector w. When we do v dot w, we are just taking the two x components and multiplying them. And we are adding them to the product of the two y components. Okay, so it would look like this, and this is just a 10 plus a negative 9, and so our dot product is a 1. All right, and that's it. So now let's do w dot v. W dot v, you're going to notice, is pretty much the same as v dot w. The only difference is you are doing the 2 times the 5 instead of the 5 times the 2, and the 3 times the negative 3. So clearly when we change the order here of the dot product, it's not going to matter. We're still going to get the same exact answer. All right, let's go ahead and do v dot v. That would mean we're doing 5 times 5 plus negative 3 times negative 3, which is 25 plus 9, which is 34. Same thing for w dot w. You're just doing 2 times 2, those are your x components, and 3 times 3, and that's 4 plus 9, which is 13. All right, now unrelated to the dot product, we're going to find magnitude of w and magnitude of v, but there is a relationship here that I just want to show you. So magnitude of w, we know we take the square root of the x component squared plus the y component squared. This finds like the length of that vector. That's going to be root 13. And then magnitude of v, again, x component squared plus y component squared. So that's 25 plus 9, that's square root of 34. All right, and you might notice some similarities with some other answers. We're going to talk about that in a second. So here are some dot product properties that you should know. If you are doing v dot w, it is always equal to w dot v. Okay, if you are doing v dot v or w dot w, it is actually equal to the magnitude of v squared. All right, well, let's look at that. When we did v dot v, we got 34. When we did the magnitude of v, we got root 34, or square root of 34. So if we are to square that magnitude, these will be the same number. Okay, and I guess actually I should have gone across, but oh well, that was number 3. The next one, if you have something written like this, this basically becomes distributive property with the dot product. So it would be u dot v plus u dot w. Okay, and then finally, if you take any vector and you dot product it with 0, v dot 0, it's just going to be 0. And this should make sense because you're going to multiply something by 0 and then you're going to add it to something multiplied by 0, which is still 0. All right, so you may have remembered learning about the law of cosines, and it actually allows us to derive a way to find the angle between two vectors using the dot product. If you really care why, you can check out page 621 on your book to see the law of cosines proof. But what this formula can be used to do is to find the angle between two vectors. Okay, so how far apart they are with the angle. And what we'll use that for is determine if those vectors are parallel, orthogonal, or neither. And orthogonal is just a fancy way of saying perpendicular. All right, so here's your formula. Cosine of theta is u dot v. So this is the dot product over magnitude u magnitude v. So this is multiplying the two magnitudes. Okay, remember magnitudes are scalar values, they're numbers, so you're just going to multiply those two numbers together. Now, a little more information for you. Parallels are considered vectors are considered parallel, if vector v is equal to some value times vector w. All right, and we'll look at that in just a second. They are also parallel if your theta is 0 degrees. All right, so take a look. Let me give you an example of this. Let's say vector v is 2i plus 3j. And let's say vector w is 4i plus 6j. We would consider these parallel vectors because you can multiply vector v by a constant, in this case 2, and when you multiply vector v by 2, you get vector w. All right, see how 2 times 2 is 4, 3 times 2 is 6. Now, another way to think about this is with slopes. We know that when we have the same slope, we have parallel lines. So think about what the slope would be of this vector, right? Slope is change in y over change in x. This guy right here is going 2 to the right and 3 up. So our slope would be 3/2. This guy is going 6 to the right and 4 up. So our slope would be 6 over 4, which is still 3/2. That tells us they're going in the same direction. They have the same slope and therefore they are parallel. Okay, so you can also think about that. Orthogonal vectors, again, are perpendicular vectors. Okay, and this means that when we do our formula above, our cosine theta equals all that, the angle between them are going to be 90 degrees, right? Because if they're orthogonal or perpendicular, they need to be 90 degrees apart. Now, something else that is true about orthogonal vectors, that's why we're talking about this within this lesson, is that when you do the dot product between them, you are always going to get a 0. All right, let me give you an example of some orthogonal vectors. Let's say we have 2, 3. I'm just writing it in angle bracket form this time. That's going to be vector w. And its orthogonal vector, I'm going to write as 3, -2. All right, now, first of all, here's how I know these are orthogonal. We should know that perpendicular lines have opposite reciprocal slopes. So use the same idea that we did above here with parallel. This guy right here would have a slope of 3 over 2. Okay, since our slope is 3 over 2, we should know that for w, if it's opposite reciprocal, or excuse me, if vector v and w are perpendicular, we would need to have an opposite reciprocal slope for the next one, which in this case is -2/3. These are opposite reciprocals, so these would be perpendicular vectors. All right, now let's see what happens when we do the dot product, because I just told you it should be equal to 0. To do v dot w, we would multiply the x components, and we would add them to multiplying the y components. 6 plus -6 is 0. Okay, that will work every single time. And again, it's because your opposite reciprocal slopes, the x and y's are switched, but one of them is a negative and one is a positive, so they'll always cancel each other out. All right, so let's go ahead and for the following problems, we're going to find the dot product and then the angle between the two vectors. And then we're also going to determine whether the vectors are parallel, orthogonal, or neither. Okay, and we're going to use the verify using the dot product, the angle, or the slopes. Okay, let me rewrite our formula just so we have it. It's going to be v dot w over magnitude w, and that's equal to cosine theta. All right, so to start, let's do dot product. Okay, that's going to be 1 times 1 plus 1 times -1, which is just 0. All right, now what that means is that we already know these are orthogonal vectors. Orthogonal. Because v dot w is equal to 0. What that also tells us is that theta is going to be 90 degrees. All right, we know that, right? If they're perpendicular, theta has to be 90. But let's just use the formula just to confirm. Cosine theta equals the dot product of v dot w, well, we just did that, over the magnitude of v times the magnitude of w. Well, the magnitude of v would be square root of 1 squared plus 1 squared, that's square root of 2. And for w, it's going to actually be the exact same thing, right? So times root 2. Well, 0 over root 2 times root 2, that's just 0. So this is saying, hey, if cosine is 0, what is theta? And it would be 90 degrees. We know that from our unit circle. Okay, let's try another one. Again, we are doing dot product. So that's 2 times 1 plus 2 times 2. Which is 6. Okay, so next we are finding the angle between the two vectors. And again, that's going to be the dot product over the magnitude of the two vectors multiplied together. 2 squared plus 2 squared, that's 4 plus 4, that's root 8. 1 squared plus 2 squared, that's 1 plus 4, that's 5. All right, if you would like to rewrite this as 6 over root 40, you certainly can. And now I'm going to go ahead and to calculate that, I'm doing the inverse cosine of 6 over root 40. And I should get 18.435 degrees. Make sure you're in degree mode here. All right, well, if our vectors are parallel, the angle should be 0 degrees. If our vectors are orthogonal, theta should be 90 degrees. This is clearly neither of those, so it's neither parallel or orthogonal. So we're just going to write neither for letter C. All right, and last one of these. Let's find the dot product. V dot W, that's 1 times 2 plus 3 times 6, which is 20. B, the angle between the two vectors. Cosine of theta equals the dot product, that's 20, over the magnitude of each of our vectors multiplied together. So that's 1 plus 9, that's root 10. 4 plus 36, that's root 40. So that's 20 over root 400, but check it out. Square root of 400 is just 20. 20 over 20 is 1. This is saying where is theta equal to 1, or excuse me, where is the cosine of theta equal to 1, and cosine of theta is equal to 1 at 0 degrees. And because we got 0 degrees, this means that our lines are parallel, or vectors are parallel, excuse me. Now, we can also see this with slopes, right? This guy right here has a slope of 3 over 1. This guy right here has a slope of 3 because it's 6 over 2. And you can also see that to get to vector w, we just multiply vector v by 2, which goes back to what we said on the previous page, where we just have to multiply the vector by a scalar value. And if we do, that's parallel. We can also see for letter A, when we had orthogonal, that we have opposite reciprocal slopes. Vector v would have a slope of 1, and vector w would have a slope of -1, and those are opposite reciprocal values, and so our slopes tell us that, again, this is perpendicular or orthogonal. All right, next, number 10, find A given the two vectors are orthogonal. There are a couple different ways to do this. One would be using the dot product, and one would be using the fact that we should have opposite reciprocal slopes. So let's go ahead and try both so that you can see which way you like the best. So if we use the dot product, we know that we should have 2 times A plus 8 times 20, which is 160. And when we have orthogonal vectors, we should know our dot product is 0. So we can just set that equal to 0, and then we can go ahead and solve this. So we would get A equals -80. So that would be one option. The other option would be to use your slopes. Here my slope is 8 over 2, which is 4. That means that this guy, if we do have orthogonal vectors, this guy has to have a slope of -1/4. So then I can go ahead and set up a proportion. I know that 20 over A has to be equal to -1/4. And we can go ahead and cross multiply, and you will still get A as -80. All right, so there are 2 ways to find that. The last thing that we're going to talk about is something physics related. In physics, it is frequently necessary to determine how much force is applied in a given direction. We can use something called decomposition of a vector to help us with this. What we do is we decompose V into 2 vectors. We call V1, which is parallel to W, and V2, which is orthogonal to W. We call V1 the vector projection of V onto W. All right, and we have these 2 formulas here for it. So let's take a minute and talk about what this actually means. All right, so basically what's happening here is we're saying that V1 and V2 are 2 vectors that we can use to create vector V. If we remember back from our day 1 notes, we can frequently add vectors or subtract them and put them together to create another vector. So that's the basic idea of what we are doing here. So let's take a closer look at what V1 and V2 are. V1 is parallel to W. So remember, parallel means in this instance that they're actually really on top of each other. The angle between them is 0 degrees. So I'm going to go ahead and draw V1 right here on top of W. And V2 is orthogonal to W, okay, which is really perpendicular. So this guy's V2. Okay, but what I'm actually going to do is I'm going to redraw V2 right here. It's still orthogonal, but what's nice about that is that it now creates this little triangle, okay, and I can see a relationship between V1 and V2. All right, if we do V1 plus V2, that creates vector V, because we started at the base of V1 and we went up V2, and where we ended, that's the terminal point. And so we can say that V1 plus V2 is V. And then if you look at this formula right here that I've given you, it's just because we subtracted V1 on both sides. All right, and then our other formula here, I can go ahead and explain that proof to you later, but really you just need to know the formula, and it's going to be really easy to actually go ahead and plug this in now. So the picture itself is more confusing than actually doing the problem. You will not have to draw the picture in the future. All right, so here's what this is going to say. Decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. Here are your two vectors, V and W, and I've drawn the picture for you. I've actually taken this from your book. Okay, but here's V1, here's V2, and what we're going to find out is we are going to be able to find each of those vectors once we complete the problem. The answers are here, but we'll see that we get the same thing. Okay, so first thing you're going to do is just find V1, and you're just going to use the formula right there. V dot W, so that's 13.11 over the magnitude of W squared. So that's going to be square root of 1 squared plus 1 squared, and I am squaring it. And then you are multiplying it by W, which is 1, 1. Okay, so now we'll just go ahead and do this piece by piece. When we do dot product, this is 1 times 1 plus 3 times 1 over 1 squared plus 1 squared is 2. So we have square root of 2 squared times 1, 1. Okay, just keep going. This is 4 over 2 times 1, 1. So that's just 2 times 1, 1, and this is just distributive property. It's just 2, 2. Which you can see is 2i plus 2j, which was written there. So we did get the same thing. So this is vector 1. You can either write it like this, or you can write it like this, 2i, I'll write it down here, 2i plus 2j. Okay, and now we are going to find W, or excuse me, we're going to find V2. V2 is V minus V1. Write that out. And we just found V1. So V is 1, 3 minus V1 is 2, 2. And we just subtract. 1 minus 2 is negative 1. 3 minus 2 is positive 1. So that means vector 2 is either negative 1, 1, or you can write it as, oops, negative I plus j, which we can see matches the answer that was given to us here. All right, so that's it. Again, don't worry about having to draw the picture. You are going to do this more probably in physics as well as Calc 3. For right now, just worry about being able to do these formulas and be able to manipulate these vectors to get your answer. All right, so V1 and V2 is all we need, and I hope you have a great day. Bye.